Okay, what I would like to talk about are basic function operations. There's an example on the board that's going to go clear across to part H. But right now, so there's an example started here that's going to go all the way to part H, which you don't see. But right now I want to get us zeroed in on the big rules here. Function operations. If you have f of g of x, if you're given f of x and g of x, so these are my two functions. You will be given f of x and g of x. F plus g of x means you simply add the functions. F minus g of x means you subtract the functions. F g of x and f times g of x mean you multiply the functions. F over g of x means put this f of x over g of x. And this is function composition. F of g of x is f of g of x. One function is going to go into another. Notice the difference between the times dot and the open ring. Okay, now what I'm going to do is I'm going to pause, move the computer so that you can see the whole example. All right, so here we go. I'm going to be using three functions. F of x is x squared plus 80. G of x is 5x plus 31. P of x is x cubed minus 10x plus 42. So if I want f of g of x, that's simply going to be f of x plus g of x. So I will be adding x squared plus 80 plus 5x plus 31. So that will give me x squared plus 5x plus 131. And that's it. Okay? F minus g of x is going to equal f of x minus g of x, which will be x squared plus 80 minus 5x plus 31. You would need to distribute the negative through, and you would end up with x squared plus 80 minus 5x minus 31. Okay, I'm going to move C down. Okay, so this is going to be x squared minus 5x plus 49. Okay, C was g minus f of x. Okay, so what you're going to have to do is a subtraction in the reverse order. G of x minus f of x, which is going to give me 5x plus 31 minus x squared plus 80, distribute. You end up with 5x plus 31 minus x squared minus 80. Okay, which would give me negative, in descending order, negative x squared plus 5x minus 59. Okay, notice it ends up being the opposites. All right, this is f times g of x. So what this is f of x times g of x. So I'll simply multiply x squared plus 81, plus 80 times 5x plus 31. Okay, I'm going to write that bigger because it looks like there's plenty of room. Okay, so that'll be x squared plus 80 times 5x plus 31. I'm going to need a calculator. All right, so under the FOIL method, that's going to be 5x cubed plus 31x squared plus 400x, and 80 times 31 is 2480. All right, so that's what f times g of x is. f times p of x. So now I'm bringing in the p. We're going to have to multiply these two. That's f of x times p of x. So that's going to be x squared plus 80 times x cubed minus 10x plus 42. So my way of doing this is to simply multiply each term. This should be polynomial times each term the longer. So that's going to be x cubed times x squared plus 80 minus 10x times x squared plus 80 plus 42 times x squared plus 80. All right, so I'm going to have to move things. All right. So this is going to be three distributive property operations. So that's going to be x to the fifth plus 80x cubed minus 10x cubed minus 800x plus 42x squared, and 42 times 80 is 3360. So minus 800x plus 42x squared plus 3360. All right, so I have like terms here ready to be combined. So that's going to be x to the fifth plus 70x squared. I went in descending order, so plus 42. This was going to be x cubed, sorry. Plus 42x squared minus 800x plus 3360. All right, I'm going to pause here and make sure I didn't mess something up. All right, so everything was fine. If I want to do g over p of x, that's simply going to be g of x over p of x. So that's going to be 5x plus 31 over x cubed minus 10x plus 42. All right. Now, I'm going to move this over. G is f of g of x. All right. I'll push this back in hopes that everything will fit when this is over. And then h, this will take less space, so I'll put h down here. G of f of x. Okay, so this is function composition. This was times. This is composition. So to do this one, I will let these replace the functions with variables that represent the functions. So f will equal x squared plus 80. G will equal 5x plus 31. Okay, I've simply renamed these as variables. And f of g of x means f of g. All right? So that means I'm going to be plugging g into f. So that's going to be g squared plus 80. So that's going to be 5x plus 31 squared plus 80. Okay? Which is going to give me 5x plus 31, 5x plus 31 plus 80. Okay? H will again need to be moved. All right. So, 25x squared. That doesn't look very neat. 25x squared plus 155x plus another 155x plus 961 plus 80. Okay? That is what we're looking at for everything. All right, so I'm going to do that again. Under the FOIL method, that's going to be 25x squared plus 155x. That looks awful. Plus another 155x plus 961 plus 80. Okay? And these two combine, so this is going to stay 25x squared. These two will become 310x, and these two will become 1041. Okay? That is f of g of x. This is different from g of f of x. Again, there's a hollow ring between these. Okay, the same thing, I'm going to let f equal x squared plus 80, and g will equal 5x plus 31. Now, g of f of x equals g of f. Okay, so f will go into the function g. So that'd be 5f plus 31. Okay? Which would give me 5 times x squared plus 80 plus 31. Because that's what f equals. So under the distributive property, this is going to be 5x squared. I'm going to need more space. So this is going to be 5 times x squared plus 80 plus 31, because that's what f is right here. So that's going to be 5x squared plus 400 plus 31. So when it's all said and done, it's going to be 5x squared plus 431. Notice that g of f and f of g are not the same. Okay? Again, notice that g of f, f of g, and g of f are not the same. Okay? Also, f times g and f of g are not the same thing. Okay? It's very important that you know the difference. I'm going to pause here and set up another example. Okay, example 2 is just going to focus on distinguishing between function multiplication and function composition. All right? So here we're going to find, given that f of x is 20x plus 32, g of x is 14x plus 17, and p of x is x squared minus 51, we're going to start with f times p of x. Well, all we need to do is multiply f of x times p of x. That's it, okay? So that would give me 20x cubed minus 102x, or let's see, 1020x. Let me double check that. 51 times 20. yeah, negative 1020x plus 32x squared, and then 32 times negative 51 is negative 1632. Getting this in descending order, I get 20x cubed plus 32x squared minus 1020x minus 1632. Okay, so that's f times p of x. F times g of x, well, it's a times dot. So it's the same thing we did here. It's going to be 20x plus 32 times g is 14x plus 17. All right. So multiplying the first terms, 20x times 14x, so 20 times 14 is going to be 280x squared. 17 times 20 plus 340x for the outer terms. The inner terms, 32 times 14, the inner terms are going to give me 448x. And then 32 times 17, 544. Okay, combining my like terms, I get 280x squared plus 340 plus 448, that times 788x. And then plus 544. All right. So that is function multiplication. This is function composition. So here I'm going to do what I did the previous example. F is 20x plus 32. G is 14x plus 17. Okay? So f of g of x is f of g. Okay? Which would give me, so f of g is I'm going to plug g into f, so that'd be 20g plus 32. Okay, I plug g into f. So that's going to give me 20. G is 14x plus 17 plus 32. I apologize that my handwriting is not the best. So that's going to be 280x plus 340 plus 32, which gives me 280x plus 372. Okay, again, notice that f of g of x and f times g of x are two different things. Similarly, I propose to go ahead and do d, which isn't on the board yet, but that's going to be g of f of x. Okay, well, what I would do is f is 20x plus 32, and g is 14x plus 17. So, g of f of x is literally g of f. So I'm going to plug f into g. So that's going to be 14f plus 17. 14f plus 17. So that'd be 14 times 20x plus 32 plus the 17. So that's going to again be 280x. 14 times 32 is 448x. Sorry, 448 plus 17. That's going to be 280x plus 465. And again, notice that g of f and f of g are not the same. All right, I'm going to erase the board and put another example up. All right. The third example, I'm going to give you f of x is x squared plus 9x plus 78, and g of x is 5x minus 205. A, find the domain of f of x, use three notations. Answer, it's a polynomial. Polynomial domain is all real numbers. So I'm going to write it as all real numbers. And I'll go ahead and write, actually I'm going to change this to 4 notations. You'll see why in a moment. So all real numbers. In interval notation, that's negative infinity to infinity. And the third notation we can use is the symbol for all real numbers. It's basically an R with 2 vertical lines. Okay? Domain of g of x. Answer, linear function domain is all real numbers. So there's all real numbers. There is negative infinity to infinity. And then there is the symbol for all real numbers again. Okay, now now the third part C asks find f over g of x. Well, do f over g of x is simply going to be f of x over g of x, which would give me x squared plus 9x plus 78 over 5x minus 205. The f of x over the g of x. Now this time it asks the domain in 4 notations. Do denominator cannot equal 0. Okay, so that means that 5x minus 205 cannot equal 0. So we would add 205 to both sides, and 5x cannot equal 205. Okay, divide off the 5x, divide off the 5, and x cannot equal 41. So there are the answer some people would just write x does not equal 41. That's a valid way of putting it. Another one is all real numbers with the exclusion that x does not equal 41. Okay, that's another way that could be written. Okay. Try to write that larger. All real numbers with the exception that x does not equal 41. Okay, I got marker dust all over my face. The third way of putting it is negative infinity up to 41, but not including 41. Union 41 to infinity. Okay, so this is from negative forever up to 41, but not including 41. Or everything after 41, but not including the 41. And then the third notation is to say all real numbers minus, you're going to use a set notation brace, 41. All right, so all real numbers minus the element 41. Okay, I'm going to pause here and put up another example. All right, I don't think I'm going to be able to fit all of these on the board, okay, at one time. So I'm going to do parts of it and erase as we go. Okay, so part A, f plus g of x equals f of x plus g of x. So that's going to be 10x over x minus 9 plus 12x over x plus 13. All right, that's it. Okay, now the domain. Remember, denominators cannot equal 0. Okay? So that means that x minus 9 cannot equal 0, x plus 13 cannot equal 0. So add 9, x does not equal 9. Subtract 13, x does not equal negative 13. So, all real numbers with the exception that x does not equal negative 13 or 9. Okay? B. F minus g of x is simply f of x minus g of x. So 10x over x minus 9 minus 12x over x plus 13. Domain. Denominators cannot equal 0. We had this discussion. All real numbers x cannot equal negative 13 or 9. Okay? C. F times g of x. Well, that's going to be 10x over x minus 9. It's going to be f of x times g of x. So 10x minus 9 times 12x over x plus 13. Which gives me 100, I'm going to lower this. 120x squared over x minus 9, x plus 13. Okay? Domain. Here, I'll go ahead and move this down. Well, no, I'm going to leave it the way it is. So the domain, same as before. All real numbers with the exception that x does not equal negative 13 or 9. Okay? So we have done A, we've done B, we've done C. D is where things start to get complicated. Okay? F over g of x will equal 10x over x minus 9 over, so I'm going to write that bigger. It's going to be f of x over g of x, which will equal 10x over x minus 9 over 12x, x plus 13. Okay? So that's going to be 10x over x minus 9 divided by 12x over x plus 13, which will be, I will change to 10x over x minus 9 times, I'm going to flip this to x plus 13 over 12x, which gives me 10x times x plus 13 over 12x times x minus 9. Okay. Now, these cancel and that reduces to 5, 6. So this is going to be 5 times x plus 13 and 6x minus 9. Okay? but the domain denominator cannot equal 0. Denominator cannot equal 0. Okay? Now, this is where things start to get a little bit more interesting. Okay? Also, if numerator equals 0, then fraction the fraction equals 0. All right. And also we have the denominator cannot equal 0. Okay? So that denominator cannot equal 0, that denominator cannot equal 0, and this denominator cannot equal 0. Okay, so x minus 9 cannot equal 0. 12x over x plus 13 cannot equal 0. And x plus 13 cannot equal 0. Well, we've had that discussion. X cannot equal 9. X cannot equal 13. Sorry, negative 13. We had that discussion earlier. Okay? So for this denominator to equal 0, that means the numerator 12x cannot equal 0. Divide off the 12, divide off the 12. X cannot equal 0. So all real numbers, with the exception that x cannot equal negative 13, 0, or 9. All right. All right, so D is done. Let me get this off the board. Well, I will now do E. E. F of g of x. All right, so picking up here, f of g of x. Okay, do. F will equal 10x over x minus 9. And g will equal 12x over x plus 13. I always replace, when I'm doing function composition, I always replace functions with variables that are equivalent. Okay, so f of g of x literally means f of g of x equals f of g. So I'm going to plug g into f. So that's going to be 10g over g minus 9. Okay, and then I'm going to replace g with the equivalent value. So that's going to be 10 times 12x over x plus 13 over 12x over x plus 13 minus 9. Okay? And the LCD is just x plus 13. So I'll just clear the rational expressions. 10 times 12x over x plus 13. Actually, I'll go ahead and do, well, no, I'm going to do it the way I was going to originally. Okay, over. That's going to, so I took this times the x plus 13. I'm going to take this times the x plus 13. Everything in this complex rational expression must be multiplied by x plus 13. So this, and this. And this cancels my denominators away. Okay? So this ends up being 120x. Okay? This one ends up being 12x. I'll go ahead and distribute this. Minus 9x minus 117. Okay? Giving me 120x over 3x minus 117. These two terms are divisible by, and this is factorable, as 120x over 3 times x minus 39. So those cancel, leaving me 40x over x minus 39. Okay, so that is f of g of x. All right, now I need to talk about the domain. Domain. Denominator cannot equal 0. So no denominator can equal 0. So as you can see, we had two things going on here. We had this cannot equal 0, and this cannot equal 0. Okay? All right, but that's simplified as, well, we already had the discussion about this one. Okay, this means that x cannot equal negative 13. All right, but this one, this expression cleaned up as that. Okay? So x cannot equal 39. So it ends up being all real numbers with the exception that x cannot equal negative 13 or 39. Okay? So that cannot equal 0, and this cannot equal 0. But by the time we were finished doing what we needed to do, that was all that was left. Okay? All right. I'm going to pause here, and we'll set up f. Actually, I'll just go ahead and erase it. Not fooling with the computer. Won't take that long. And I have f. G of f of x. Okay, once again, I'm going to start with the new variables. F equals the f of x, and g equals the g of x. All right, so g of f equals, I'm going to plug f into g, so that's going to be 12f over f plus 13. And that's going to give me 12, f is 10x over x minus 9, over f is 10x, x minus 9 plus the 13. Okay? And the LCD of the whole thing is x minus 9. So I'm going to multiply everything by it. 12 times 10x over x minus 9 times x minus 9. Over 10x, x minus 9, times x minus 9, plus 13 times x minus 9. And as intended, the denominators will cancel. So I will just end up with 120x. I'll go ahead and distribute here. I will have 10x plus 13x minus 117. And that will simplify as 120x over 23x minus 117. Okay? The domain. Denominator cannot equal 0. So at any step, if there's a denominator that equals 0, we have to exclude the value that would lead to it. So obviously x minus 9 cannot equal 0. We had that discussion in part A, x cannot equal 9. Okay? We also cannot have this being equal to 0. 10x over x minus 9 plus 13 cannot equal 0. Well, folks, when we did everything we needed to do with that, we ended up with 23x minus 117 cannot equal 0. Okay, so add 117. 23x cannot equal 117. Divide off the 23. And x cannot equal 117 23rds. All right, so I'm going to use a decimal approximation to determine which goes in what order. That's 5 point something, so that's higher. So all real numbers, we're going to list them in order from least to greatest. This is 5 point something. 5.086956, blah, blah, blah. Okay, so this is less than that. So all real numbers, x is not equal 117 23rds or 9. All right. That's it. I'm going to pause here and set up another example. All right, example 5. F of x is square root of x minus 140. G of x is 6x squared plus 17. A, find f of g of x. Do A, f of g of x would be f equals square root of x minus 140. G equals 6x squared plus 17. All right, so f of g equals, let's extend this out, I'm sorry. F of g will equal the square root, g will go into f, so that's going to be the square root of g minus 140. Okay? Well, folks, g is 6x squared minus 17, or plus 17. I'm going to put it in parentheses, minus 140. Well, folks, the parentheses aren't really needed, so that's going to be square root of 6x squared plus 17 minus 140 will give me the square root of 6x squared minus 123. All right? B is a different story. G of f of x will equal, well, to do that, f will equal square root of x minus 140. That's the way I do it. And g will equal 6x squared plus 17. All right, so g of f will equal 6 times f squared plus 17, because f is going into g. So 6f squared plus 17. And f is the square root of x minus 140 That's going to be squared plus 17. Well, folks, the square root of 140 squared is just going to leave me the x minus 140. Because the square root squared just leaves me that quantity. Just leaves me the radicand. So I end up with 6x minus 840 plus 17. So that's going to be 6x minus 823. And again, notice, folks, that f of g and g of f are two different results. That will usually be the case. Exceptions can only happen under very strict circumstances. All right. And C. G of f of f, or g of f of x, will equal g of x minus f of x. So 6x squared plus 17, so that's g minus the f, minus the square root of x minus 140. That's it. That's as far as you can go. Okay? Sometimes they're going to be that easy. D. F times g of x. So f times g of x. That's a times dot, folks. Well, folks, that's simply going to be f of x, square root of x minus 140, times 6x squared plus 17. Folks, that's f times g. That's f of g. Notice the difference. Times dot, open circle. Try to make it bigger for emphasis sake. All right, well, folks, this is just going to be a distributive property situation. So that's going to be 6x squared times square root of x minus 140, square root of x squared minus 140, plus 17 times the square root of x minus 140. That's it. That's as far as we can go. I'm going to pause here and set up another example. All right, I have moved the computer, and once again, these are the reminders of what everything means. Example 6, I got f of x equals 13x squared plus 30, and g of x is 21x minus 40. All right, so A asks for f of g of x. Do. Well, folks, this is just simply f of g of x. That's it. Okay, it's the same type of problem. So I would start with f equals 13x squared plus 30, and g is 21x minus 40. So f of g is going to go into f, so that's going to be 13g squared plus 30. So that will be 13, g is 21x minus 40 squared plus 30. Okay, so that's going to be 13 times the quantity 21x minus 40 times 21x minus 40. I'll put that in brackets, plus 30. All right, so this is going to be, under the FOIL method, that'll be 441x squared minus 840x minus another 840x plus 1600 plus 30. I'm going to distribute these. This will be 13 times 441x squared. So I'll distribute these after they're combined. So this is going to be minus 1680x plus 1600. All right? That's going to be a distributive property situation. Okay, and I will need a calculator for this. So 13 times 441 is 5,733 x squared minus 21,840x plus 20,800 plus 30, which ends up being 5,733 x squared minus 21,840x plus 20,830. All right, so that is f of g of x. This is g of f of x. So this is g of f of x. F equals 13x squared plus 30. G equals 21x minus 40. So g of f equals, f is going to go into g, so that's going to be 21f minus 40, which will be 21 times 13x squared plus 30 minus 40. Distribute. I'm going to need a calculator. 21 times 13 is 273 x squared plus 630 minus 40. That's going to be 273 x squared plus 590. All right. And that's it.